day, everybody. This is Chris, and this is going to be a video that is going to act as a supplement for the assignment that I'm working on. This is lesson 4 of medicinal chemistry, and this will be specifically in regards to part 1. In part 1, the setup is as follows. We have a 24-year-old female who weighs 135 pounds, and she was caught for suspected DUI, driving under the influence, and blood ethanol level was detected or was drawn, and she had a blood alcohol concentration of 0.157%. All right, and we can assume that 0.08% is the legal limit. So clearly she's over the legal limit. Furthermore, she reports to her lawyer or to the defense team that she consumed 4 5-ounce glasses of wine at a concentration of approximately 11% ethanol alcohol. In addition to that, she consumed 1.25 fluid ounce shots of vodka at 80 proof, 80 proof being about 40% ethanol by volume. So I'll just throw that in there at 80 proof. All right, and she reports consuming this over approximately a 4-hour period of time. All right, so what the question says is, look, she's probably toast because she's clearly over the legal limit, but what's going to happen is she could potentially get in more trouble if she goes to court and it's found out that she's lying. And so the question is kind of set up where, look, she claims all this has happened. You know that the prosecution is probably going to work backwards from this blood alcohol concentration and find out how much ethanol she consumed over this 4-hour period. And if their predictions don't line up with what she reports, well, then that may indicate that she's lying. And that could be additional trouble for her, as she's already in trouble. So it kind of throws this in your lap and says, all right, well, figure out what's going on here. So I think what I'll do is I'll just go ahead and work backwards. I'll do exactly what the prosecution will do, and I'm going to work my way backwards and find out, based on what she reports here, what would her blood alcohol concentration be? What's the prediction? And does what we predict line up, match with what she reports? Or what was actually reported, which is what was actually assessed. Okay, so to do this, I think the first thing that I want to do is, the first thing I need to do is I need to find out how many grams of total ethanol she's actually consumed. And so what I need to do here is I need to convert these values into grams of ethanol. So what can we do here? Well, what do we do? I think the first thing to do is to kind of look at this and go, okay, well, let's start here with the wine, okay? So the wine is 11% volume of ethanol. So 11% of the volume of that wine that she's drinking is going to be ethanol. So let's do this. Let's go ahead and start here, and let's take she had 5 ounces, right? So 5 ounces, and I'm going to multiply that by 11%. Or 0.11, okay? And I want to find out what the volume actually is that she consumed. So of those 5 ounces, 0.55 ounces of that ethanol, of that total glass of wine. For every glass of wine, 0.55 ounces is actually the ethanol. All right, and then what I'm going to do is I'm going to move down to the vodka here, and I'm going to go, okay, well, let's see, vodka's 80 proof, which is 40% alcohol, or 40% ethanol. And I'm going to do pretty much the same thing there as well. So let's just go ahead and do that. So 1.25 ounces times multiplied by 40% or 0.4. All right, and that's going to give me about 0.5 ounces of the 1.25 ounces is actually ethanol. All right. Okay, so then furthermore, what I need to do up here is I need to multiply this value, because this is per glass here. I need to multiply that by 4. All right, and then that's going to give me 2.2 ounces. All right. And then I have 0.5 ounces here, and that's going to give me a total of 2.7 ounces. All right, so we'll kind of throw that number. The total ethanol consumed over a 4-hour period is 2.7 fluid ounces. All right. We may have to do some more work on that, but there we are. Okay, so what are we going to do next? Well, I think what I want to do next is I know that probably the formula I'm going to have to use needs to be in kilograms, okay? So I'm going to take her weight, so step 2 we'll say here. I'm going to take her weight 135 pounds. All right, and I know that there are 2.2 pounds per kilogram, so I'll divide that by 2.2 to convert that to kilograms, and that's going to give me 61.4 kilograms. So her weight, or her mass rather, but I'm just going to put weight, is 61.4 kilograms. Okay, alrighty, now what I'm going to do is I'm going to put up a formula that's commonly used. This is known as the Widmark formula, W-I-D M-A-R-K, Widmark. There we go, the Widmark formula. And the Widmark formula is as follows. The blood alcohol concentration equals, okay, A, and I'll tell you what all those things mean here in a minute, divided by W times R, that value minus this beta factor here times H. That's our Widmark formula. So A is the grams, the total grams. Okay, so these are the total number of grams of ethanol ingested. W is the patient's weight in kilograms. All right. R right here, this value R is a constant. It's a factor. It's called the Widmark's factor, constant / coefficient. All right, and it varies a little bit between men and women. Men typically have a little more body water than women. So the factor is a little different. For a male patient, you're looking at about 0.68, and for a female, you're looking at about 0.55. Okay. This beta here, this is a beta factor. The beta factor is it's a kind of an elimination constant. This beta factor right here, it's kind of an elimination constant in human beings. It actually takes on the units of grams per yeah, this will be grams per liter per hour, because that's elimination constant. Whereas the Widmark's factor is going to be liters per kilogram, because it's talking about body water, so we're talking about distribution. Okay, we're talking about a distribution constant there. Okay, this also varies. the beta factor, the elimination constant, varies between men and women. So in the male, you're looking at, actually this doesn't really vary between men and women, excuse me. What it does is it varies in how much ethanol you consume. The typical unit though, the average unit that we use for this factor is 0.15 grams per liter per hour. All right, so that's what we're going to start off with using. All right, so what I need to do is I need to take all this information up here and I need to plug it into this formula. So I want you to kind of put those in the back of your mind here. And all of this happened over a 4-hour period. And the final part of the Widmark formula is H, which is the total number of hours that this was all ingested over. All right, so there's our formula. Here's all the information up here that we need to throw into the formula. So what I'm going to do is I'm just going to clear this out here, and I'm going to rewrite the formula here. All right, BAC equals A divided by W multiplied by R less beta multiplied by H. All right, so there's my Widmark formula. We said that this patient has a weight of 61.4 kilograms. She's a female, which is relevant. We have 2.7 ounces, fluid ounces of total ethanol consumed, and we're looking at a 4-hour period of time. Okay, so let's start plugging in numbers here into our formula. So A is going to be the grams ingested. I'm going to come back to that. Yeah, what the heck? Let's just do it now. Okay, so I have 2.7 ounces of ethanol. I need to figure out how many grams. So I need to go from ounces to grams. And the conversion factor is 1 ounce of ethanol is equivalent to 23.3 grams of ethanol. All right. So we'll just do a quick dimensional analysis. We administered, or she took 2.7, she ingested 2.7 ounces, and I don't know how many grams. To solve this, I just cross multiply here. 1 times x just gives me x. 23.3 times 2.7 gives me 62.91 grams. All right, so now I know what A is, right? A is 62.91 grams of ethanol. All right, so I can just kind of plug that right in there since I figured that out. Then I'm going to plug the patient's weight in kilograms. I've already figured that out. That's 61.4. And I always like to put my units in these formulas like this, just so I can kind of keep track of those units a little better. Let's put R in. R is the Widmark's, what we call the row factor. In the male, it's 0.68. In the female, it is 0.55. So I'm going to throw that there. And of course, that's a distribution constant, liters per kilogram. Okay. And then I'm going to move up here to my beta factor. And we're going to go with an average, so like an average social drinker. And I am going to throw that factor, which is 0.15. So 0.15 is the average. And then let's see, the units of the beta factor is, let's see if I can pull this out of my, I don't want to give you guys the wrong units. Let's see, Widmark's is, see, the beta factor is an elimination factor, which is going to be grams per liter per hour. So That's grams per liter per hour. So that's why I like to throw my units here, because the units really let me know what I'm actually talking about. That this guy down here is a distribution versus an elimination factor. And then H is going to be 4 hours. All right. So there's going to be some cancellation that'll occur when we do this formula. Okay, so now all I have to do is I just plug and chug. I just plug the numbers in, I chug them, figure out what I'm dealing with. So what I'll do is I'll just change colors here. So I'll just multiply this one out real quick. I can get there pretty easily. So what we'll do is I'll just drop an arrow down here, and then put subtract. And I'll just put what I get here, which is, let's see here, 0.6. All right, 0.15 multiplied by 4, and you can just pull your phone out if you want, your calculator, and you can just go ahead and do that calculation. And actually, it's just a pretty straightforward plug and chug formula at the end of the day. It's so 0.15 multiplied by 4 gives me 0.6. Okay, and then same thing here. What I'll do is I'll multiply these two first. 61.4 multiplied by let's see, 0.55, and I'll multiply that by 0.55. That gives me 33.7 downstairs in the denominator, so 33.7 7 here, and then I'll put the kilograms up here, which is 62.91. All right, and then the blood alcohol, and then let's just go ahead and divide this since we've got there. So 62.91 divided by 33.77 gives me 1.86, and that's going to be subtract 0.6, which is going to equal, let's do that, 0.6 is going to equal 1.26. And this particular concentration is in grams per liter. When I cancel all of these things out here, my hours, my kilograms, I'm going to be left with grams over liters. So that's my blood alcohol concentration, and that 1.26 gram per liter is just going to convert to 126 milligrams per deciliter. Okay, deciliter is 1/10 of a liter. Okay, so I just did a basic conversion there, and that is going to give me an ethanol level. Okay, if I convert that to a percentage, that is going to give me a percentage of 0.126%. Because percent is always grams in 100 milliliters, right? So 1% would be 1 gram in 100 milliliters, or 1,000 milligrams in 100 milliliters. That would give me 1%. Well, this isn't even 1,000 milligrams, it's only 126, so my blood alcohol concentration is 0.126%. Okay, so what I've done is I have used the Widmark formula to backtrack, right? I'm doing exactly what the prosecution would have done, and if you go back to the original problem, her blood alcohol, her ethanol level was 157 milligrams per deciliter, or 0.157%. So there is a large discrepancy here. This is much too large for me to, even looking at uncertainty of measurement, I really would have a very hard time working with that. I really would. So is she lying, and is she going to get into more trouble? Well, possibly. I'm going to just erase all this stuff real quick here. Possibly. However, there are a couple things that we need to be very careful about. Okay?